Okay, now we're going to use our knowledge of the factor theorem and the remainder theorem to fully factorise a polynomial and find and express a polynomial as a product of its factors. So how we start with this process is we ultimately want to find a factor of the polynomial that when we apply the remainder theorem, we end up with a remainder of 0. So where we begin is we focus on the constant term of the polynomial and we start with the factors of that constant. So look at factors of negative 21. They would be negative 1, positive 1, negative 3, positive 3, negative 7, positive 7, negative 21 and positive 21. And we think about all of these factors. And what we're going to use is the remainder theorem to see which one will satisfy and give us a result of 0. So I'm going to start with a factor of positive 1 because that's the easiest place to start. So that means I'm going to substitute into my polynomial p of 1, a factor of 1. Okay, and we end up with 1 cubed minus 11 times 1 squared plus 31 times 1 minus 21. And in doing that, 1 minus 11 is negative 10 plus 31 minus 21 gives me negative 10 plus 31 is positive 21 minus 21 is 0. So that means that x minus 1 is a factor of our polynomial px. Now, if this is a factor, that means I should be able to take this polynomial, apply the process of long division and divide it by x minus 1 and then end up with a result of 0. Because it should divide evenly. So let's have a look at doing that now. So x minus 1 into the polynomial, which is x cubed minus 11x squared plus 31x minus 21. Now remember the process. Dad, mother, sister, brother. Repeat. Dad, mother, sister, brother, repeat. First thing I'm going to do is divide. So x cubed divided by x is x squared. So I divide and then I multiply. X squared times the x, which is x cubed, and x squared times the negative 1, which is negative x squared. After multiplying, I subtract. Negative 11x squared minus negative x squared becomes plus x squared, and that gives me negative 10x squared. After I subtract, I bring down the next term, which in this case is 31x. Now, after I brought it down, I repeat the process. So I divide. Negative 10x squared divided by x gives me negative 10x. Multiply negative 10x times this whole term here, x minus 1, gives me negative 10x squared plus 10x. Okay, after I've multiplied, I subtract. So let's subtract. 31x minus 10x is 21x. Negative 10x squared minus negative 10x squared is 0. I've subtracted. Next, I bring down my next term, which in this case is negative 21. And now repeat the process. And I start with dividing. 21x divided by x is 21. Now multiply. 21x minus 21. I've multiplied. Now I subtract. And can you see these are like terms, so therefore my result is 0. Now remember, this is what we want to happen because we've shown previously that if we apply the factor and remainder theorems and substitute our root of 1 into the polynomial, we should get a result of 0. So now I want to express this polynomial as a product of its factors. So we're saying now that therefore x cubed minus 11x squared plus 31x minus 21 is equal to x minus 1 times x squared, our quotient that we've just attained, minus 10x plus 21. Now hopefully we can see that we can further factorise this quadratic trinomial here. And we're looking for factors of positive 21 that combine to give us negative 10, and they would be x minus 3 and x minus 7. So now I want you to think about this result for a moment. Remember we said earlier that we were going to start by trying to find the factors of the polynomial by looking at the constant. And we just started with 1, and I selected 1 to see and verify if that was going to be a root of my polynomial. But hopefully you can see now, once we fully factorise this, that we could have tried back here p of 3 and we would have ended up with a result of 0 as well. And if we tested p of 7, we also would have ended up with a result of 0 because these are all roots of the polynomial. So this polynomial, which is a cubic function, has 3 roots, 1 at 1, 1 at 3, and 1 at 7. Its leading coefficient is positive, so that's one that's going to be going up as x increases. So we can see how long division, factor and remainder theorems, and curve sketching are all interrelated.